So question is in front of us. What's the answer for this question? Can anyone give the answer for this question? Question is out of convex or plano convex and concave lens of equal focal length, an image with minimum spherical aberrations can be produced by. So you should know about a spherical aberration. What is spherical aberration? I hope you know. If you don't know, so you should know. You should know. So I will give you options. Okay, any lens, convex lens, and this, and this, and this. So correct answer is plano convex lens. So image with minimum spherical aberrations, we use plano convex lens. So you should know this concept. If you don't know, so please don't attempt these questions. Okay. So plano convex lens. Okay, yeah. The next questions. Okay, a converging lens is used to form an image on a screen. So when the upper half of the lens is covered by an opaque screen, so these options you can go through the options and this will happen. This will happen. So correct answer is this and this and this and this and this and this. So correct answer is B and D are true. So intensity of image will increase. So basically what we are, the intensity of image will decrease. So obviously intensity of image will decrease. Okay, because we are covering, so intensity of image will decrease and no part of image will disappear. So again, this is good question. Good question. You know. If you don't know, you don't know. So you should know these concepts. So next questions we are really getting forward by convex lens. When it is cemented with the concave lens, again the real image convex lens when it is cemented with a concave lens. Okay, so basically we are using convex lens and concave lens. So correct answer, shift away from the lens system, shift away from the lens system. You can go analyze, you will find the correct answers. Next, we are moving for next question. A convex lens always gives a real image. This I don't want to read and all this because you know I don't know. The worst two statements are this, yo. So correct answer is 2, 3, and 4. So concave lens always give virtual image. Yo. Convex lens give also magnified virtual image. Yo. And most important, concave lens can be made as a convergent lens with suitable medium. Yo. Okay, so you can make this lens to convergent lens, Keep this braining, I don't know. Yeah. So if you know, you don't know, right? Shut up. Yeah. We are moving on. Next questions. Okay, let's look at you. So, and acoustic combinations will produce this. So it means unaffected by variation of refractive index with wavelength. Okay, with wavelength. Okay. So image unaffected by the variation of refractive index with wavelength. Okay. So next we are going for next questions. Next we are going for next questions. We have questions is a double convex lens of focal length F is cut into 4 equivalent parts. One cut is perpendicular to the axis and other is parallel to the axis of the lens. The focal length of each part is what answer? So answer is 2F. I don't want to explain because I don't know. And so you should know. Okay, yeah. So I'm moving for next questions. Next question is how convex lens of glass immersive what's a complete which power is its power is yeah. So you should know these questions. We don't know, please. I also don't know, so don't mind me. Yo, and next questions we have. So pilot rays applied some focus on the thin convex lens. Thin convex lens. Thin, listen. We are using convex lens. And it's thin. Yeah, so thin concave lens of the same focal length is then joined to convex lens, and the result is that this. You should go through the options, and this what will happen. The focal point shifts to the infinity. The focal point shifts to the infinity. The focal point shifts to the infinity. Okay, next questions we are moving for. The graph drawn with the object distance along abscissa x and object distance along ordinate y-axis. Measuring the distance from the concave lens is it's easy questions, global questions given in all the books. Okay, so its question is hyperbola. So hyperbola. Okay, so measuring distance from the convex lens, the graph between the object distance along abscissa axis and image distance So see this take care of this object on x-axis, and we are putting image on y-axis. So this will be a hyperbola. So I hope you know. Okay, if you don't know, please don't attempt this question. So stay away from. Okay, this questions, type of questions, subscribe. Okay, discussions. Yeah. When we move on next questions, a lens that has convex surface at one side and concave surface on another side behave as yo. It's a good question. It's a good question. It's a good question. Good question. The options are in front of you, and all this correct answer is C and D are true. So convergent lens when the radius of convex surface is less than radius of concave. Okay, so you can go through this. Okay, so I'm showing you because it's important. Yeah, and diverging lens when the radius of curvature of the concave surface. Okay, lens. Okay, so the radius of curvature concave surface like that of the convex lens. Okay, so you should know all this concept in your brain. So next we're moving for next questions. Okay, so next questions we have is yeah. So if a convex lens is dipped in a liquid whose refractive index is equals to the refractance lens, I already this question, so you should know. Basically, we are taking convex lens, okay? So plain parallel glass plate. Next questions we are doing. A lens has a convex surface one side, and concave surface another side. If the radius of curvature of convex and concaves are equal to r, it's equal to r. If the mu is the refractive lens, that is it's easy question, doable questions. Okay, so if you know the basics, if you know the concepts, definitely you can do this question. So correct answer is infinite. You can go to the calculation because I don't know calculation at all. So if you know, you know. So you can go to the calculations and you can do these questions. Okay. So next questions we are moving for. So spherical air bubble in water will act as it's a good question, very good question, very famous questions. If you know, you know. So in this question, so a spherical air bubble in water will act as a concave lens. Okay, as a concave lens. Okay, concave lens. Okay. Concave lens. Take care of concept celebrate. Next questions we are moving for. Okay, sure. Consider the following demand B. So this. Go through option. Go through option. Go through option. So here, a plano convex lens behave as a convergent lens, irrespective of the radius of curvature of convex surface. Okay. Plano convex lens behave as a convergent lens, irrespective of the radius of curvature of convex surface, and the focal length of glass plate is 0. Focal length of glass plate is 0. Yo. Okay, next question we have this again. So, assessment we have achromatic combination of lens needed for the minimization of chromatic aberration. A single lens alone cannot satisfy the conditions of minimization of chromatic aberration. What's the correct answer? Both are correct. Okay, so and achromatic chromatic combination lens is needed for the minimization of chromatic minimization. You want to minimization the chromatic aberration. You know what is chromatic aberrations, and a single lens cannot alone satisfy the condition of minimization with the chromatic aberration. Yes. It's correct. Yeah. It's correct. Yeah. Next question we don't to minimize the spherical aberration. Choose the correct among the following. Okay. Yeah. So focusing the incident light on more curved surface of the plano-convex lens, focusing the incident light on more curved surface of plano-convex lens to minimize the spherical aberrations. Okay, yeah. Next questions we are moving with. Okay, the failure of the pixels and marginal rays passing through the same point on the reflection at spherical mirrors or refraction through a lens is known as. I don't know. What's answer? The spherical aberrations you should know. Okay. So it's known as spherical aberrations. Okay, so I am not going to deep analysis because I don't want to discuss deeply here. Oh yeah, next question we are going to. So closed lens is used to minimize the spherical aberrations, in which ratio of radii of curvature lens is the ratio. Closed lens is used to minimize the spherical aberrations. So ratio is -1/6. Ratio is 1/6 radio curvature in the ratio of -1/6. Next question we have, if omega is the dispersive power and f is the mean focal length, then the longitudinal chromatic aberration is, what's the correct answer? Omega into f. You should know the longitudinal chromatic aberration is omega into f. Next question we are moving with defects of vision. So hypermetropia. Long side effect. Next question we are moving it. Okay. This we have table one, this, table two, table two, table two, table two, table two, table two. So this options we have, and the correct answer is okay first. So basically we are talking about myopia. So myopia will goes to okay concave lens. Myopia will goes with concave lens. Myopia will go is concave lens, and a hypermetropia obviously will convex, and presbyopia will go with for bifocal astigmatism. Astigmatism will be cylindrical lens. Astigmatism cylindrical lens. You should use cylindrical lens for astigmatism. Sure. Next questions we are moving with. Okay. So an object at different distances are seen by the eye. Which of the following remains constant? Okay. The object at different distances are seen by the eyes. It's easy question. Anyone will do this question. Image distance from eye lens. Okay. So image distances from eye lens. Okay. So an object at different distances are seen by the eye. So are seen by the eye. Object at different distances are seen by the eye. So which of the following remains constant? The image distance from the eye lens. Okay. Next question. In case of hypermetropia, this options, you can go through the options. So the image of near object is formed behind the retina. In case of hypermetropia, next question we are moving with the image of an object formed on the retina of the eye is. I don't know. So answer real and but a real is and what a real and but a real and but a. Okay, next question we are moving with myopia is due to I don't know what's the answer. So myopia is due to the elongation of eyeballs. You should know all these concepts. Easy questions. Anyone can do this question. So myopia is due to elongation of eyeball and a myopia persons cannot see distinctly the near objects, the far objects, neither near or far. This correct answer is far objects. So myopia persons cannot see distinctly the far objects. So I hope this is clear. Okay.